Hello, this is going to be the lesson for 12.3 Inscribed Angles. There's two theorems and there are three corollaries that you need to know. The first theorem, 12.11, is called the Inscribed Angle Theorem. To make sure that you understand the vocabulary term inscribed angle, the definition of inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So the term that we had learned before was central angle, where the vertex of the angle was the center of the circle, and the sides or the legs or whatever you want to call them of the angle were the radii of the circle. This time we have what's called an inscribed angle, where all three endpoints are along the outside of the circle. So the first theorem says that the measure of an inscribed angle is half of the measure of its intercepted arc. So basically, whatever the measure of the arc AC is, and we learned how to do that back in chapter 11, whatever the measure of arc AC is, we divide that by 2, and that'll give us the measure of angle B. Okay, so again, I had said last chapter that what we learned in that chapter was going to help us with this chapter. So if you forgot about arc measures, you may want to go back and take a look at that. The second theorem you need to know is theorem 12.12. It does not have a name. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So if you take a look at the picture, you see on the first one right here, on that circle, you have the circle and you have a chord BC, and you have this line that is tangent. And the angle right here is created by a chord and a tangent line. And so the measure of that angle is half the measure of the intercepted arc. The intercepted arc is this red arc right here. Okay, so the measure of angle C is 1/2 the measure of arc BDC. Same thing on this one too. The three corollaries that you have here are also very important. First one is that two inscribed angles that intercept the same arc are congruent. So notice here that they both intercept this arc. This angle right here, its endpoints are the red arc, and then this angle, both of its endpoints are the arc. So they have the same exact arc that they intercept at, so that means that the angles are congruent. Second corollary, if you have a angle that is intercepting a semicircle, then the measure of that angle is 90. And the last corollary, if you have opposite angles of a quadrilateral inscribed in a circle, then those opposite angles are supplementary. So basically, angle B and angle D are supplementary, angle A and angle C are supplementary. Okay, those arcs are not drawn for congruency, they are just drawn to point out those specific angles. This is one of my favorite things in geometry. I love circles, they're so much fun to me. This particular set of information, inscribed angles and inscribed chords and semicircles and all these things, this has all been this actually is really my most favorite thing in the entire course. I don't know why, this stuff just seems fun and it's easy for me. Hopefully you'll find that it's not too difficult. Hopefully so far you found that this chapter hasn't been too challenging. But again, as I've stated in the past, and I tell you guys every day, if you need help, don't be afraid to come talk to me because I'm happy to assist you. So I'm going to do a couple examples using these corollaries and these theorems, and then you guys can be prepared to work on the assignment in class when you get there. Okay, so our first example says to figure out what the values of A and B are. A is an arc, B is an angle. Now, if you look at this problem, it's based on practice and just consistently doing problems like these. You'll find that one letter is usually going to tend to be easier and better to find first than the other. In this case, if you look to see what you have, A is created by this arc. That's something you're going to want to look for. You're going to want to look to say, okay, well, what is creating the letter that, basically what shape am I looking at and what creates that shape? So in this case, A is an arc. Well, what creates an arc? Well, in this chapter, inscribed angles create arcs. So what inscribed angle is creating that arc A? Because if I look to figure out what inscribed angle is creating that, I probably know information about that inscribed angle that will help me, and I can use one of the theorems or the corollaries. Well, one of the things we learned was that if an inscribed angle that's creating an arc, the inscribed angle is half of the measure of the arc. So we know that the measure of angle PQT is 1/2 arc PT. Well, the measure of PQT is 60. We don't know what PT is, but we know it's A. Multiply both sides by 2, so A is 120 degrees. We just used theorem, the inscribed angle theorem, theorem 12-11, to assist us on that. Okay, now B, we can figure out pretty simply now, because B creates this intercept arc, that's A, and 30. So basically, B is equal to 120 plus 30. Now, remember that it's half of that. Okay, so we have to add those two together, that's 150, divide that by 2, and that's 75. Okay, next question, example 2, says in circle O, what is the measure of angle A? Well, we see here that this is a diameter, and we learned that in one of the corollaries that if you have an inscribed angle that is basically creating a semicircle, then the measure of that angle is 90 degrees. It's a right angle. So that was pretty simple. Our answer is 90 degrees. Okay, next one, example 2. Oops, forgot next up there. Sorry, example 3. It's getting late. What is the measure of angle 1? Well, in this case, angle 1 is this angle right here, and notice that this is diameter, semicircle, so again, pretty simple. Angle 1 is 90 degrees. Okay, next one, in the diagram at the right, what is the measure of each numbered angle? So we have to figure out at the end what is the measure of angle 1, angle 2, angle 3, and angle 4. This is one of those questions where you're going to have to recognize a couple things. You're going to have to use the theorems and the corollaries. If you look at what we have so far, the simple ones to figure out are angle 1 and angle 3 because they're both creating a semicircle. So basically here what we can do is say, oh, well, angle 1's 90 and angle 3 is 90 as well. Okay. We also know that angle 4 is equal to 1/2 of the arc, that is 60 plus 80. Well, 60 plus 80 is 140, so angle 4 is half of 140, which means that angle 4 is 70. The last thing is that this is a quadrilateral, so that means that in total, all the angles together add up to 360. Another thing to recognize is that because it's a quadrilateral and it is created by angles that are inside of the circle and the quadrilateral is inscribed in the circle, the opposite angles, according to the third corollary, are supplementary. So angle 2 and angle 4 are going to add up to 180 degrees. And we know what angle 4 is. We just figured it out. It's 70. So basically all we have to do is 180 minus 70, and that will give us angle 2. And that's pretty much it. Okay, next question. I don't know what example number I'm on. I think 5. In the diagram, SR is tangent to the circle at Q. If the measure of arc PMQ is 212, what is the measure of angle PQR? So we're looking for the measure of this angle right here, and the arc that I'm highlighting in red is the one that we know. It's 212. According to theorem 1212, the angle that is created by a tangent line and a chord is half of the measure of the intercepted arc. So basically, angle PQS is equal to 1/2 of the arc PMQ. And arc PMQ is 212, so this is equal to half of 212. Now, recognize in the picture that PQS, PQR are supplementary because they form a straight angle. So all we have to do now is subtract 106 from 180, and that's our answer for the question. Last example. In the diagram at the right, KJ is tangent to circle O. What are the values of X and Y? I would like for you guys to work on this one on your own. I would like for you to bring the answer to class on Friday, or whenever we go over this with you in class. So please bring the answer to this one. I'll check it for you. Bring all of your notes with it too, so I can so you can use them. But make sure you bring the answer to example 6 so I can check it and we can go over and talk about it. Hope you guys have a good evening.